Hi guys, let's look at the next exercise in this chapter, Pythagoras Theorem. But before we start, let's quickly revise what is Pythagoras Theorem. We've been doing it for a couple of years now. So it is applicable only for a right angle triangle. The side which is opposite the 90-degree angle is known as the hypotenuse. And let's say the other sides, we call them as side 1 and side 2. So we could name them whichever way. In this case, Pythagoras theorem states that hypotenuse square is equal to side 1 square plus side 2 square. So in case we name this as A, B, C, then the Pythagoras theorem would state that AC square is equal to AB square plus BC square. So that's the basic Pythagoras theorem, and in this exercise we'll use this Pythagoras theorem to prove certain equations. So let's look at question number 1. Question number 1 says, in the given figure, AD is perpendicular to BC. We need to prove that C square is equal to A square plus B square minus 2AX. So we have two right angle triangles. So let's apply Pythagoras theorem in both of them. So in a right triangle ACD, using Pythagoras theorem, what we get is b square is equal to h square plus x square. So that's my equation number 2. And let's see if I apply it in the other right triangle, what do I get? In a right triangle ABD, using Pythagoras theorem, what I get is c square is equal to h square plus a minus x whole square. So that's my equation. What I have to prove is c square. So I have c square on the left hand side. On the right hand side, I need a square, b square and 2ax. So I can have a square from here, x square from here. I will get 2ax also, which means I need to replace the value of h. So what I get is from 2, what I have is h square is equal to b square minus x square. So yes, I have taken h square on one side, b square minus x square. So we will put equation 5 in equation 4, and what I get is c square. Instead of h square, I put b square minus x square, and the second element remains the same, a minus x whole square. Let's open this bracket. So this is b square minus x square. This is in the form x minus y whole square. So this is first term square plus second term square minus 2 times first term into second term. Anything gets cancelled? Yes, x square and x square gets cancelled. So what I have is c square is equal to a square plus b square minus 2ax. So that's what they wanted us to prove. So hence proved. So my suggestion for such questions from this exercise is that you look at what you need to, where you need to go. So I looked at my left hand side. I realized that I've already got my left hand side. So in case on the right hand side what they do not want h square on the right hand side in the question. So I replaced h square. So you need to figure out where you need to reach and accordingly substitute values. Let's look at another question. So the next question that we do is question number 2. It says in equilateral triangle ABC, AD is perpendicular to BC. Let's just draw a rough diagram. So this is an equilateral triangle ABC, ABC, all three sides are equal. AD is perpendicular to BC. So AD is perpendicular to BC. Next, BC is equal to x centimeter. So this is x centimeter, which means AB is also x, AC is also x. Find in terms of x the length of AD. Now we know the perpendicular from the vertex will bisect the base sides, which means BD and CD are equal. Let's just write that down. Point number 1. Perpendicular from vertex bisects base in case of an isosceles. In this case, it's not even isosceles, this is equilateral. So we will write it equilateral triangle. So what we get is, therefore, BD is equal to CD is equal to BC upon 2, which means BD is equal to CD is equal to X upon 2 centimeter. So this is X upon 2, this is also X upon 2. Now in a right triangle ADC, we have, using Pythagoras theorem, what we get is AC square is equal to AD square plus DC square. AC square is equal to X, AC is equal to X, X square is equal to AD square. We do not know, we need to calculate the value of AD, and DC is equal to X by 2 whole square. Since triangle ABC is equilateral, therefore all three sides are of equal length. Next, let's open this bracket and see what we get. So we get X square is equal to AD square plus X square upon 4, which means X square minus X square upon 4 is equal to AD square. I took X square upon 4 on this side, which means taking the LCM, 4x square minus x square upon 4 is equal to AD square, which means 3x square upon 4 is equal to AD square. Taking square root of both sides, I get AD is equal to x root 3 upon 2 centimeter. So that's what they wanted us to calculate, the length of AD in terms of x. So AD will be equal to x root 3 upon 2. Let's look at the next question. The next question that we do is question number 3. Question number 3 says ABC is a triangle right angled at B. Let me just draw a rough diagram. Right angled at B. Okay. Next point. M is a point on BC. Okay, so M is any point on BC. Let's just mark M here. So what we have to prove is AM square plus BC square is equal to AC square plus BM square. Now I noticed two right triangles, ABM and ABC. Let's try and use Pythagoras theorem in both and see what do we get. So point number 1, in a right triangle ABM using Pythagoras theorem, what I get is AM square is equal to AB square plus BM square. So they want AM square on the left hand side, so I've got AM square for sure. Let's see the second one. So number 3, in a right triangle ABC using Pythagoras theorem, what I get is AC square is equal to AB square plus BC square. Yes, AC square is equal to AB square plus BC square. So they want me to add BC square to AM square. I've already got AM square on one side. From the second equation, I get BC square. Let me just change this in a manner that BC square is on one side. So from 4, what we get is point number 5, which is BC square is equal to AC square minus AB square. I took AB square on this side, so it became AC square minus AB square. So I have on the left hand side, what they want is AM square, which is here, and they want BC square, which is here. So let's just add these two equations. So add 2 and 5, and what I get is AM square plus BC square, which is my left hand side, and on the right hand side I will have AB square plus BM square. This is from equation 2, and from equation 5 I have plus AC square minus AB square. I notice that AB square and negative AB square gets cancelled, so I have AM square plus BC square is equal to BM square plus AC square. That's exactly what they wanted us to prove, so hence proved. Again, I hope you notice the method that I have used. I figure out what do they want me to prove. So on the left hand side, I kept used the Pythagoras theorem and I kept the two elements that they wanted. I just added because the sign in this case was addition, and then whatever got cancelled and we were left with the final answer. So fairly simple till now.